off here.
We did 16 too.
Okay. Don't think we did 17. I do remember doing 16. I
Yeah.
don't remember doing 17. Or did we?
Yeah, we did 17.
Okay.
I think we stopped at 18 because it was just a hard one.
Okay.
We had like a minute left, and you said
Okay.
that's for later.
That sounds about right. I do kind of remember doing 17. So let's pick up with 18. Let me blow it up just a little bit here. Let me move everything out of the way. And make that bigger. Okay. So she drove to the circus at an average speed of 30. She returned and averaged 25. And I want to know how many miles she drove on her return. She took a total of 2 hours and 12 minutes.
All right.
What is the formula that we need to use to solve this? Involves distance, rate, and time.
So X.
You want to have it
X.
memorized.
Right.
Let's always start out with the general formula.
And it like distance times rate equals time.
Well, it's distance equals rate times time.
Oh, okay.
The way to think about this is if you drove for 60 miles an hour, for 1 hour, you'd go 60 miles. If you drove at 60 miles an hour for 2 hours, you'd go 120 miles. But this is the one you want to memorize it, and you want to memorize it in this form. Of course, that also means that rate is equal to distance over time, or time is equal to distance over rate. In other words, all variations of this thing. But you don't want to memorize all the variations because that just makes it confusing. So you want to memorize one form of it only.
Right.
You can always work out the algebraic manipulations of it.
Right.
So
we have the time, which is 12 hours and 12 minutes.
well, it's 2 hours and 12 minutes.
2 hours, which is,
But that's the total time. So we've got to break this. We got to break this down. This is the primary formula that controls all distance, rate, time problems. Okay.
Okay.
But this is a two-step problem because she goes at one rate and she comes back at another rate. So how many miles did she drive on her return? So let's let D sub 1 equal the way out, and D sub 2 equal the return.
Right.
So D sub 1 is equal to what?
Sorry, my computer is. It like went to sleep for a second. Let's see. D1.
I'm going to turn my camera off because my computer's protesting also.
All right.
Okay, you don't need to see me. D1 is equal to what? It's equal to R1 times T1.
Right.
What's R1?
Okay. R1 is 30.
We don't know what T1
wait, did you
is.
say?
We don't know what T1 is yet.
Okay.
What's distance 2 equal to?
25T.
Times T2, which is the time it takes her to return, which we also don't know.
Right.
Okay. However, we do know that this distance is the same as this distance. So I can set this equal to that because I can really say that D1 is the same as D2. So I can just say the distance that they're asking for is equal to that.
Right, so it'd be, oh,
So what's
so
the
it could
total?
be,
What's the total distance?
30t equals 25t,
Well, 30t plus 25t
equals d.
times. Now, notice that if I rearrange this thing, that the total time is equal to d over the rate. Hold on a second. Let's see. We know the total time, and we know the total distance. Now, it is true that 30t is equal to 25t. Sub 1 equals 25t sub 2. Because this d is equal to this d. So I can
Right.
definitely make this statement as one of my equations. The other equation is that the total time taken is equal to the total distance divided by the average rate. So we've got 2 hours and 12 minutes, which is 1/5 of an hour. So 2.2 hours is equal to total distance, which is this, 30t sub 1 plus 25t sub 2 divided by the average rate, I don't know why this is giving me trouble. It is. I'm trying to think of what. We know the total distance. We know it took 2.2 hours to go 30t sub 1 plus 25t sub 2 all over our average. We know that R is equal to 2D divided by the total time, which is 2.2. Okay, so for R, I got to put 2 times D, which is this plus that, all over, it doesn't do any good. Hold on one second.
All right.
Tell you what, for the moment, let's go on. Let me look this up later. The important thing here is to know that distance equals rate times time. And
yeah.
This is a complicated distance rate time problem, and I'm a little confused about the second sentence. It says she returned home along the same route and averaged 25 miles per hour. I'm not sure if they're saying she averaged 25 miles per hour for the whole trip or 25 miles per hour on the way home.
I think it was just on the way home.
I think so too, but I'm not sure. And I don't want to waste any more time with me fumbling around trying to figure out how to solve this. So let's go on. That never is any good. We'll come back to 18. I'll make a note about 18 and we'll come back to it. But for now, let's just go on. All right, we're going to go to section 7. About number 1.
Right. So if A equals that, 6A.
If 6A,
so should we?
if 6A equals
Should
48,
we?
what's A equal to?
8.
Okay. So if A equals 8 and A times B equals 1, what is B equal to?
1 divided by 8. 1 over 8. So B.
Correct. Number 2.
B.
B?
Yes.
Good. You don't even have to do any math, notice on that.
No. Yeah. I mean,
It's approximately a 2-to-1 ratio, right? A little bit more than 2 to 1?
right.
Oh,
And the only one close enough to 10 is 11.
Exactly.
And 22 is way too high.
Right. And 4.4 is way too low.
Right. I like how they put most of the answers like in order.
Well, I think they do that. I think they do it that way to give an advantage to the people that recognize that you don't always have to do the math.
Right.
In other words, if you're sharp enough to see that, then you don't have to waste time figuring out what 4.4 divided by 2 is and then multiplying that by 5.
Right.
Okay. They always reward the people who see the shortcuts.
Right. All right, let's see. How would you do this one? Because I know it's just they just cross multiplied to get it together, and so it'd be 7x over 5y.
Well, if you cross multiplied, you'd get this. 7x equals 5y.
Oh.
So how do I get the value of 7x divided by 5y? What do I have to do this?
And you could do the cross multiply thing and then work it out there.
Well, how about if we take this,
Figure out.
we cross multiply to get that. Now if we want to know what 7x divided by 5y is, let's divide both sides by 5y. Now what's 7x divided by 5y equal to?
1?
Yep.
Oh, okay.
Now the other way to do this problem would be, well, I know what this part is. It's 5/7. So what I'm really looking at here is 7 over 5 times 5/7.
Right.
Because they told us that x over y is 5 over 7. And then when I do that multiplication, I get 1. Okay?
Okay.
Okay. Can we figure out x and y individually?
Yeah.
Okay.
Yes.
What's x?
X is 90 degrees.
Well, this is 90. X is the measurement from here to there.
Oh.
What's this angle?
So
What's this angle right here?
that's 30 degrees.
Okay, so what's x?
120.
Okay. What's y?
Y is 180.
What's x plus y divided by 2? What's x plus y divided by 2?
150.
Okay. Usually these kind of problems, the last part's the easiest part. The toughest part is figuring out what x is and knowing that if this is 30, this has to be 30. If that's 30, then x has to be 30 plus 90. All right, let's look at number 5. They like these kind of problems on the test.
Yeah.
What's one way we could do it?
Hold on a second. We just add the number of each one, so it'd be 5 times 2. So then add that to 30 plus whatever 1 hour and 20 minutes times 4 is. Right?
Okay. So 1 hour and 20 minutes times 4 is what?
It's 4 hours, 5 hours and 20 minutes.
Okay. So the total amount of time is what? Back to the beginning.
Right.
We got 40 minutes and breaks.
6 hours.
Okay. So when do we start?
Should start at 9 o'clock, I mean. No, sorry, 8:50, 8:30.
It's going to have to be a 30.
Yeah, I didn't see
I'll
the
tell
30.
you right offhand if it was 8 or 9 without doing a little more math, but I know it's got to be a 30 because it's an even 6 hours. There's only one answer that's got a 30 in it. Now, there is another way to do this problem, and let me just point it out because it might actually be a little easier. And that's let's back solve it. Because they're not always going to give you the answers that would all end in 30, and then you'd have to figure out what starts 6 hours prior to 2:30 exactly. It turns out that that's 8:30 for sure, but it's not always easy to figure that. You can't just do math to do it. You kind of have to count the hours out. But let me explain what I mean by back solving. Or better yet, why don't you tell me how to do this back solving it? What would I start with?
You take 8:30
Okay, you wouldn't want to start with 8:30 Because if that wasn't the correct answer, we don't know anything other than it's something later.
Oh, so you would take
Start with the second.
230. Oh, second?
Start with 840.
Right.
And I'll tell you why. Okay, so we're going to assume that that thing is 840 right here. Okay, so if it started at 840, when did it end? It's an hour and 20 minutes.
240.
No, it's an hour and 20 minutes. I'm just doing row by row is what I'm going to do.
Oh, if it was an hour and 20 minutes later, it'd be 10 o'clock.
Okay. First break would go from 10 to 10:05. Next class would go from 10:05 to what? It's an hour and 20 minutes later.
So 11:25.
Okay. Then we have lunch, which goes from 11:25 to where?
It's half an hour, 11:55.
Okay, and then we have another break that goes 11:55 to noon.
No, it's a class.
Excuse me. So that class goes from 11:55 to 1:15.
Right.
And then we have
5-minute break.
So it goes from 1:15 to 1:20. And then we have our last class would go from 1:20 and get done at 2:40.
Right.
What does that tell me? It tells me I got to start earlier than 8:40.
Right. And so the only answer is 8:30.
Exactly. But now do you understand why when I back solve I don't want to start with 8:30?
Right.
Because when I back solve this problem, if I don't have the right guess, I'm going to know exactly which way to go.
Right.
If I came out with 2:20, I'd know I need a later time.
Right.
But the reason you start with the second lowest is because if it's clear that I got to go lower, I'm done with the math. I know the answer is A.
Right.
If I needed to go higher, the next one I'm going to try is D. Now, and then I would know the answer because either D would be correct or I'd know I need to go higher or lower. So I would know immediately what the correct answer was after trying B and D. And that's the classic back solving. Now, in this particular case, I'm not sure that back solving was necessarily shorter, but you always are going to get the right answer. There's no way I can screw it up by back solving.
Right.
Unless I add an hour 20 wrong. But I'm not likely to do that. I actually prefer the way you did it. And I think that that's probably the proper way to do this problem.
Okay.
But I never want to underestimate back solving because a lot of problems that where you can't figure out how to do it, you can do it by back solving.
Right. I'm so confused by reading this problem.
Okay. What's median mean?
Average.
No, that's mean.
Oh, median?
Yeah, you have mean, median, and mode. All three
It is the
nodes.
middle number.
Okay. And they're not telling us which order these are in, so we don't know which is the middle number.
Right.
But they're telling us the middle one is this one here. So we do know the middle one. X plus 4. We just don't know the first one or the last one. It could be 2x minus 8 and 3x minus 13, or it could be this order. See the difference?
Yes.
Okay. So which of, this is a beautiful back solving problem, and in fact I'm not sure there's any other way to solve it. You see how we're going to back solve this?
Yeah.
Okay. Now this one we wouldn't necessarily know which way to go if we were wrong. So on this one I would start with A. Could A work? What is, when you substitute 6 for x, what do you get for these three numbers? Let's go with this order up here, because it's either 1 or number 2. So you get 4, 6, 4, 10, and 5. That doesn't work, does it?
Right.
Because 10 is not the median of those three numbers. 5 would be.
Right.
So see if 6 works down here. Well, I know it doesn't because we're going to get 5, 10, and 4. I don't even need to do the math. It's just the opposite. So 6 is not an answer. Let's try 8. What do you get here?
I get. I'm doing the second way for some reason. I've been doing 3x minus 13 and then go.
Doesn't matter. Either one. Either one.
11.
We're just going to switch the numbers if the first one doesn't work. So what's this?
11, 12, and 8.
So this doesn't work, and if I switch the 8 and the 11 around, it also doesn't work. So it's not 8. Let's try 11.
I get 20, 15, and 14.
Ah, that looks like a median, only not in that order.
Right.
But it works for this one here, because this would be 14, 15, 20.
Right.
So 11 can be a value for x that makes x plus 4 the median of these three numbers.
Right.
That's all the further we need to go. Now,
Okay.
the reason I didn't start with B was because I knew that if 6 didn't work, it wouldn't tell me a whole lot. I wouldn't necessarily know that I needed a bigger number. I mean, obviously all of these are bigger, but notice that if I'd have started with 8 and 8 did not work, I didn't have any idea where to go next. I didn't know whether I needed higher or lower. So that being the case, I started with the lowest numbers first because that makes the math the easiest. It's easier to substitute 6 in for each of these than it is a 2-digit number.
Right. Right.
So that's why I did 6 and 8 first, because the math was easier. And then we got to 11. Luckily, they didn't make 15 the correct one. It would have taken longer.
Right.
And that one, I'm not sure how to do that without back solving, number 6. And there are a lot of problems on the test that are kind of like this. So you need to really, really get used to the back solving method.
Right.
To the point where when we're practicing, if there's 2 ways to solve it and one's back solving, I'd almost like to see you do that just to practice your back solving technique. You know what I'm saying?
Yeah.
That last problem we did, the time problem. You actually solved that easier algebraically, but I wouldn't mind seeing you go through the back solving process just to practice it.
Right.
All right, let's go to the next one, number 7.
Alright,
So his net profit, which is P, and don't be confused by that. That just means P is a function of B. Oh, I just love it when they mix up P's, B's, C's, E's, D's. It makes it real hard to talk about it. You got to be very careful. So I could write this as P equals 2.5B minus 100. It's a little more mathematical to write it as P is a function of B, and it's equal to that. So that's all that means.
Right.
Well, how many books must she sell in order to earn a net profit of $225?
Okay, so it would be
What two techniques
2.5
to solve this? We got our technique for algebraic, back solving, or picking numbers, making up numbers for B, and see if we could do it that way. Generally, those three techniques are the techniques you want to use. You were about to do it algebraically. That's fine. Let's do it. Do it algebraically for me. What's the next line I want?
to solve for B, so it'd be B.
What goes here?
It'd be 25.
225.
225.
In other words, they're saying
Right, the number 9.
earn a total profit of 225. How much does B have to be? So solve that for B.
225. Right. Okay. So now we divide, add 100.
Okay.
So it'd be 325.
Can you tell the answer now without even looking at your calculator based on their possible answers they're showing?
Yes.
What is it?
It's 13.
130.
130. Yeah.
That's what you meant, right?
Yeah.
Because, in other words, you're right, it's 13, but that's not on there. The order of magnitude was off by 10. But you realize that when you looked at the answers. Okay, now tell me how you would do it back solving it. Where would you start?
Take 225 and plug it in there.
Okay, so I'm going to take what's that number equal to? Use your calculator.
2.5 times 225 minus 100. 462.5.
What's the answer based entirely on that?
Lower.
Exactly. All right. Cool. Let's go to the next page, 312.
Yeah, it was a long day today.
What's that?
It was a long day today. Just
Was it?
tiring.
Yeah?
Yeah.
When's your SAT? It's not this coming Saturday?
The ACT is next Tuesday, and the SAT is the week after that on Saturday.
Okay.
So the 23rd is the ACT, and the 4th of May is the SAT.
Okay. Well, that'll be a good week for you.
Yeah.
Those are brutal. All right. This problem number 8 requires you to know something that I try to get people to memorize. And that is, tell me what this is, first of all. Without foiling it. You remember what it is?
I know this.
Like I know this. I don't remember but I know this, and
You got
you're
to
gonna
know.
say
Well, I'm going
I
to
don't
help you
remember.
remember how to do it. Tell me what a plus b squared is.
Isn't that the equation for like a perfect triangle or something?
No, no, you're close. Trust me, the way to solve this is to know this, and you need to know this anyway. Go ahead and FOIL it out if you have to. What's that equal to? A plus b times a plus b. Well, FOIL it out.
I don't know.
What's the first? First, outside, inside, last. A
I'm
times
confused.
a. Well,
I thought. Sorry, for some reason I was still looking at the other one. Okay, so it'd be a squared plus b squared.
not if you're foiling it. If you're foiling it, it's first, and then outside, which is a times b, and then inside, which is another a times b, and then last is b squared. So this whole thing becomes a squared plus 2ab, always, plus b squared. This is what you want to memorize right there. And what is a minus b quantity squared equal to? This is the other one you want to memorize.
1, like the same.
A squared minus 2ab plus b squared.
Plus 2. Okay.
Now, notice the differences and the similarities. They're exactly the same except for the sign on the middle term. So really, if you can memorize that one, you can always figure out this one.
Right.
So you really only have to memorize one of them. Okay? Now, what is x minus y squared equal to? Based on this.
Based on that, it'd be x squared minus 2xy plus y squared.
Okay. So that's what it is. What have they given us? X squared plus y squared is 153, and they've given us xy equals 36. So what is this whole thing equal to?
100, no.
Yeah, 153 plus what? Or minus what?
153
That's
minus,
this part, and that's this part and that part. So that's 153 minus 2. What's xy?
2,
xy given to us in the problem. What's xy equal?
36.
So it's 153 minus 72.
Okay.
81.
All right.
And that's, in other words, only after writing this do you see why we can now solve the problem, because they've given us x squared plus y squared and they've given us xy. It doesn't become apparent that you can do that until you start taking steps. In other words, when you see a problem like this and you have no idea what to do, start doing anything. And the only thing we can do is to multiply x by y, x minus y, and square it, which we did in this step here. Now, you could have foiled it. You didn't need to have this thing memorized.
That's just the extra step.
On this test, this comes up so often that you want to have this memorized, this one and this one.
Okay.
So that you don't have to foil it by hand up top here like this. Ever. You don't ever want to have to do that. You want to always have it memorized. And they structure their questions so that they depend on you having that memorized sometimes. For example, let me give you another one. Tell me what this is.
Now I have a question. Should we just, like, is it safe to just stick that in the calculator?
Well, you'll have a problem doing it, I suspect, but I don't want you to use the calculator on this one. This problem actually came off of a test that you're not allowed to use the calculator on.
Okay.
The only reason I'm giving it to you is I want to reinforce this principle of question 8. If you're looking at this, that looks a lot like what? X squared minus 2xy plus y squared.
Right.
That whole thing is supposed to be equal to x minus y quantity squared, when x is equal to 100 and y is equal to 99. So if all of this is equal to what? Would be 100 minus 99 squared, which is 1. So by recognizing that this is a squared minus 2ab plus b squared, I know that that's a minus b quantity squared.
Right. Okay, that makes sense.
Okay? So knowing that formula can come in handy when they give it to you in reverse, where they want you to go the other way, where it would be really hard to unfoil that thing. But by knowing that other thing, then you can solve the problem. All right, let's look at, now figure not drawn to scale, okay, so we can't depend on looking at it graphically.
Right.
Let's see, I've labeled it, they tell us that AB is 1. They tell us that's a right angle. And they tell us that BD is 2 root 2, which they labeled. And they want us to give them the value of Z.
All right.
Which is an angle.
Right. So we know that x equals 45 degrees.
Okay.
And z must be smaller than 45 degrees.
Not necessarily.
Oh, z and y must equal 90 degrees.
That's true.
What
measurement are we going to need to figure out angle Z?
The other leg of the ABC triangle.
In other words, BC, right?
Right.
And then maybe AC. But once we know BC, this is a right triangle, we'll be able to figure out AC using the Pythagorean theorem. So if we can figure out either AC or BC, we'll have a shot here. Well, you already said this was a right triangle, 45, 45. What are my normal dimensions on a right triangle? 1, 1, square root of 2. So this being 2 square roots of 2, what's this dimension?
2.
Okay. So if that's 2, and that's 1, what kind of triangle is this? If I orient this ABC triangle like this, I know it's a right triangle because this is the 90 degree. Here's A, here's B, here's C, and I know that this is 2, and this is 1. Do I know what kind of triangle this is? It's one of those special triangles. What is it?
What is it called? I cannot, the 40, 40, 90 triangle?
This is the 45, 45.
45, 45,
What's the other special one?
The
30, 60.
30, 60, 90, you're right.
And this is a 3060 because I could use the Pythagorean theorem to figure out that that's square root of 3, but I don't really need to. In other words, I don't need to know this. What I need to recognize is that once I get a side of 1 and a hypotenuse of 2, this is a 3060 triangle, which makes Z 60.
Right.
Now, is there another way we could have figured that? Let me think for a moment. I don't think so. In other words, we know this is 45. That's 45. That's 90. So we could say, and we know that adds to 90, but without knowing one of these sides, I can't figure out these two angles. The moment I know one of these sides, I could use a trig function. You've had some trig, right?
Yeah.
Okay, well notice that I don't really need to recognize this as a 3060 triangle. They're just asking about that angle, theta. Well, the cosine of theta is equal to 1/2, which means theta is the inverse cosine of 1/2, which you could look up on your calculator and it'll tell you 60 degrees. But those two triangles are very key, and that's why at the beginning of this, every one, they give you this information.
Oh, okay.
Notice our two special triangles are right here. There's the 45-45 with dimensions 1, 1, square root of 2. And here's the 3060 with dimensions 1, square root of 3, 2. The key one is the 1 and the 2. We don't really need the square root of 3. The 1 and the 2 tell us that it's a 3060 right triangle. Okay, number 10. What two ways?
The problem just looks at one.
I know it. Well, that's a good hint at something. When the problem looks like it's too difficult to put into an algebraic equation, what's another way to solve it?
Just working through it?
Back solve.
Back solving.
Check and guess is what they call it. Or, I'm sorry, guess and check. In other words, guess at the answer and see if it fits all the numbers. So I'm not sure when we do that whether we're going to be able to know which direction to go. However, what I do know is it's going to be hard to take 15% of 35 and 45.
Right.
So I'm going to start with 40, one right in the middle. So we're going to assume what? Work me through it, how we're going to back solve this. We're going to say h equals 40 for starters.
Right.
Okay, now let's see if that's a true statement.
So 15% of 40 is 6.
Hold on. Okay. Hold on, let me think of something here. 20% of 30% of a positive number. So we're going to let x equal the positive number. Not so easily back solved.
Yeah.
However, now we're in position to write the equation. If x is my positive number, let's forget h being 40. Let's write an equation. In other words, if I'm going to solve it algebraically, which after I investigate solving it with back solving, I realize there's a problem. But
Right.
now let's try to solve it algebraically. And whenever you try to solve a word problem, your first step should be this: defining your variable and saying what it is. So now let's put this into an equation. What does it mean 20% of 30% of a positive number is equal? That's the left side of the equation. So how would I write that?
0.2 times 0.3 times, is equal to,
Hold it. Of a positive number, so there's something else, times what? Of is always means multiply.
right, times x
Okay?
equals 15 times h.
15%, which is 0.15,
Right.
times h of the same number. Another
Right.
multiply. Now, can you solve that for h?
Yeah. So you do divided by 15,
Okay.
0.15, sorry.
What's the first thing we do with what can we do with the x's?
Oh, minus x for both sides.
No. Divide by x. In other words, the x's cross out. We're going to divide both sides by x. That turns into a 1. That turns into a 1. So now it's 0.15h equals 0.2 times 0.3, which is 0.06, not 0.6.
Right.
We know it's got to get less, not bigger, so it can't be 0.6. Now, what's 0.06 divided by 0.15?
0.4.
Which is what percent?
40.
Okay, that's the
So it
answer.
worked.
Well, not really. We didn't back solve it. Remember, I started to back solve it, and I saw that there was going to be a problem, and that we still didn't know the positive number.
Right.
Now, we could have made up a positive number and solved it, back solving. That's the way to back solve it, would be to pick numbers and back solve. But the moment you define this positive number with a variable x, it actually becomes quite easy to solve it algebraically. And you still there? Joel?
Hello, you there?
I heard the tone. I heard you go off. Can you hear me?
Yeah, I can hear you now.
Okay, good. So, in other words, it wasn't real clear how to set this up algebraically until we defined that variable. And then it became easy. And believe it or not, that is the secret to all word problems. If you merely start off by defining a variable and saying what it is, the rest of it comes rather easily.
Right.
Without struggle. Now, let me just illustrate the third technique, which we haven't come across yet, which is to pick numbers and back solve. Well, in this case, the positive number can be anything we want. X, notice the x is canceled. X could have been 10, x could have been 100. And it didn't matter to this problem. So let's try to back solve it. Let's let x be 100. Let's let this positive number be 100, which is okay to do. Okay. 20% of 30% of that positive number is equal to 0.06, because 20% is 20, 30%, it's 6. And 15% of h% of the number has to be equal to 6 also. Well, if I try each of these answers, 40 is going to be the only one that works. In other words, I've got to have 15% of 40% of 100 has to be equal to 6.
Right.
And when I try 40, it will work. None of the others will. And it wouldn't have mattered whether I had let x be 100 or I could have let x be 1,000.
Yeah, it didn't matter what it was.
Value for that positive number. It didn't matter what the positive number was.
Okay.
That would be an example of picking numbers and then back solving, as opposed to solving it algebraically.
All right, cool.
All right? All right. Well, let's call it a session. And we'll pick up, let's see, I've got a session with you scheduled for Thursday.
Yes.
I got Marina at 4:30 and you at 5:30.
Yes.
Okay. Talk to you Thursday.
All right.
All right,
Bye.
Joel. Bye-bye.